Software development carries with it some fundamental concerns. 1, how to increase productivity. 2, how to reduce the demands of maintenance. And 3, how to save money. These concerns are central to the business decisions of software development firms everywhere, and they are timely questions. The first, how to increase productivity, is vital. The current demand for skilled software engineers is expected to keep rising for the next 20 years. The second, how to reduce maintenance, is just as vital. Managers may be caught between hiring freezes and the need to maintain released software. Eliminating bugs during development could help reduce the load of maintenance. And the third, how to save money, is as vital as it is obvious. Managers need to keep costs down, even while the size and complexity of their projects are going up. Meet Linda Zimmern, a software development manager in Digital's Commercial Languages and Tools group in Nashua, New Hampshire. Several years ago, Linda's team took on a project, the version 2 release of an automated software testing system, the DEC Test Manager. She was concerned with all 3 questions: increasing productivity, reducing maintenance, and keeping costs low. It was a good, though junior, team of developers.
We had a very senior principal engineer who'd been at DEC for a long time. We had another engineer, a senior engineer, who'd been at DEC for about 2 years, right out of school. We had another engineer who'd been at DEC for less than a year, straight from school. And we had a college hire who had come to us right from school.
The project schedule was tight.
Because of the pressures both internally by our other layered products groups, by SQM, the Software Quality Management Group, as well as from the customers who needed this type of tool, our marketing organization asked us to deliver something in less than a year's time.
The project itself was quite challenging.
The team was very interested in giving this a try. They were very interested in the technical challenges that this version was going to enable them to work in. And so they were taking the risk. And in fact, we had told our manager, yes, we can do this full steam ahead, even though we hadn't really a clear idea how we were going to make it happen.
In all, Linda's team started where most teams start, uncertain about the problems that lay ahead, but determined to work hard. But Linda's team had an advantage most teams don't have: Digital's family of productivity tools, the software development environment. With that advantage, they met their commitments. This 5-member team released version 2 with 60,000 lines of new code. Code that not only worked, but was designed to be reusable and has been reused many times over. In all, a stunning achievement in productivity and reducing maintenance. And
what we did develop was under 7 months from inception to delivery of the product.
They did it with 5 months to spare. And they did it with Digital's software development environment, a family of tightly integrated software development tools designed to streamline and simplify every stage of the software development process. Currently, Digital offers 11 software development tools, and they do everything from manage the source code files to running the system builds and tests. They even record the history of the project, so newcomers can get up to speed quickly and easily. Let's look at 3 of these tools that Linda's team used: VAXnotes, Digital's online conferencing tool; the Code Management System, or CMS; and the Performance and Coverage Analyzer, or PCA. The first job was to work out the product requirements. For this, they used VAXnotes, Digital's online conferencing system. Notes conferences can be on any topic and can be private or open to worldwide access. Linda's team opened their conference to specific users throughout Digital.
We opened up a notebook using notes, and we put in a first pass at our requirements, and we asked our internal users worldwide to please comment on what they saw and to give us additional requirements. So we could keep what we had as the original note and then a number of replies to that with additional requirements.
A VAXnotes user can enter a topic or several topics for discussion. As others read through the conference, they can enter their responses, bring up new issues, refute, and support ideas, or, as in Linda's case, suggest product requirements.
And we got requirements from Japan, from Hong Kong, from Europe, as well as from the United States. It was a very effective means of getting the requirements. This enabled us to really speed up that phase of the project.
Linda's team continued to use VAXnotes throughout development to track discussions about design, analysis, and coding. The team then moved into prototyping, where they created very preliminary versions of their new software and sent them out to selected users to get their input. They used a tool called CMS to manage their source code modules. CMS, the code management system, is a library utility that stores and manages files and records valuable information about them. It keeps track of every CMS transaction, who creates a new module, who retrieves it, when, why, when it's returned, as well as all the changes made to it. CMS lets several developers work on the same modules at the same time, even branching off on completely different development tracks. When they're ready, CMS lets them merge their final versions together. Very valuable for prototyping.
CMS will allow two developers who've worked on the same version of a file to merge those back together, and if they haven't touched the same section of code, it will merge them back easily. If they have touched the same section, it will flag it as merge conflicts and will enable the user then to know exactly what they have to resolve by hand. We did thousands of merges during the prototyping phase. We would never have been able to do the prototypes as quickly as we did and move into the implementation phase.
Code development proceeded rapidly. The team made a rule for themselves. No one could put a new source code module into the CMS library unless they put in a test for it as well. But how could they tell if the test was doing its job, testing all the different paths in the code? That is, what was the coverage of their tests? They used the Performance and Coverage Analyzer, VAX PCA, to find out.
We had a very high goal for our coverage of 90%. In order to do that, we had to start getting measurements early on of how we were doing by code path for the software that was being developed. When the developer would write a test script for the software that he just had developed, he could run it using PCA and get a coverage of that test on the piece of software. So he could see, well, he'd only covered about 40% of the code paths with his test. He could analyze using the analyzer component of PCA what he hadn't covered, plot that out, get information, histograms by line of his module, and then go back and update his test accordingly.
PCA also helped them identify some major trouble spots in their code.
One of our early base levels, a particular function was slower than it had been in version 1 of the project by a factor of 100, which was pretty significant. We started using PCA on that module. We found that we had done some of the algorithms were not the most efficient. By just enabling PCA to give us that data, we speeded up that particular module so that the functions were equal in performance with what was already in the field. And it only was a matter of spending a week and a half using PCA to do that.
By the end of 7 months of development, the DEC Test Manager had 87% test coverage. The person responsible for bringing the software development environment into wide use in Linda's group is Tom Harris, a group engineering manager in Digital's Commercial Languages and Tools group in Nashua, New Hampshire. Tom began to encourage the use of the tool several years ago. It was clear to him they needed some changes in the way their group did business.
Basically, we wanted to decrease capital spending by about 30% to meet some company budget policies. We wanted to continue with flat headcount to meet all existing commitments and to be able to move into new business areas as well. This meant that with a set of people and a set of products already in place, we wanted to be able to run smaller support teams and smaller, faster-moving development teams.
Tom was facing the same concerns every software development manager faces: increasing productivity, reducing maintenance, and saving money. Once again, Digital's software development environment was key to the achievement of these goals.
The purpose of the software development environment is to apply technology to the problems of producing high-quality software on time and maintaining software in a wide variety of environments with very small numbers of people. Software development environments certainly don't solve all the problems of programming groups, but they can certainly take a number of the hassles out of the way. Our software development environment that we use within this group includes a number of tools which are very tightly integrated, which take a lot of the manual steps out of the process of producing high-quality software. And we think that that helps quite a bit. It causes projects to be more consistent, it causes them to be more predictable, and it lets us run projects with fewer people at higher levels of reliability than we ever have in the past.
Integration is the key to the software development environment. Many of the tools automatically call and access other tools. For example, the Module Management System, Digital's automated system builder, examines each of the source files it needs to perform a build. If any need to be recompiled, MMS simply pulls them from the CMS library and compiles them. Then it continues with the build. This kind of transparent integration pays off in many ways. For example, by reducing the demands of software maintenance, organizations have more time to explore new opportunities. This is a common situation in many companies. With each new software system delivered, more and more of a group's resources are confined to maintaining those products. Bugs must be found and corrected, new releases planned and implemented, customers' questions answered. With each release, their freedom to move into new ventures decreases. By using a family of integrated software tools, a group can radically reduce the demands of maintenance.
The important thing about that has been that the need for a large maintenance team has really been reduced. We can maintain a 200,000 line program now with 1 or 2 people, not 4 or 5 that it used to take in the past.
The software development environment tools reduce the demands of maintenance in 2 ways. First, new people joining the team can get up to speed much faster. And second, the use of software development tools promote product reliability. Getting new team members up to speed quickly is of major importance when maintaining software products. There needs to be a simple way to give new members all the folklore of development, the specifications and requirements, the design decisions, all the discussions that went before that shaped the work of maintenance. VAXnotes provides all this. A VAXnotes conference consists of one file, easy to back up, easy to copy and store. All the folklore is there, all the decisions and the reasons behind them, all the design rationale. With all that available to them, new members can get into their work sooner. A new hire can also get up to speed faster using the language-sensitive editor along with the source code analyzer, 2 more tools in the software development environment. The language-sensitive editor is a text editor that provides templates suited for each programming language. The editor provides complete templates for most language-formatted routine constructs. For example, if-then statements, variable declarations, subroutines, and so forth. During an LSE session, a new user can open up a second window and run the source code analyzer. SCA is used to analyze and understand complex software systems. It lets users navigate through software systems of any size or complexity. It cross-references information within a single module or across thousands of modules. The SCA can locate every reference to a variable name.
Request the language-sensitive editor cooperating with the source code analyzer to pull up the next module which references those changes, and the next module after that, and the next module after that. So a new person coming in the group can make changes to 20 or 30 modules within a 1,000 module application without necessarily knowing the name of even one module.
Ramp-up time for new members on Tom Harris's team has dropped from 6 months to a few weeks using these tools.
Looking at the size of maintenance teams elsewhere within the industry, it appears that there's some major opportunities for reducing those teams if companies can go to standardized sets of tools. Standard set of tools allows your maintainers to do things consistently, and you can move them between projects and maybe even ramp down the size of maintenance teams over time.
The other way to reduce maintenance is obvious, releasing more reliable products. And the biggest barrier to having high reliability and low defect counts is the difficulty in testing.
The COBOL compiler, before we ship it, has a set of 20,000 test programs that we run. Now, a set of 20,000 test programs produces a set of test result listings that are nearly as tall as I am. It would take days and days to go through those. If you have 3 or 4 tests that fail and you have a stack of paper that's 5 or 6 feet high, then someone may or may not actually see where a test failed because there's so much information in test results typically. We'd run all the tests end to end. Figure that's going to eat a computer for 3 or 4 days, and everyone else on the computer is going to hate you. Do you run the test? No, probably not.
The DEC Test Manager eliminates both of the problems Tom identified. First, DTM can run test subsets instead of the whole body of tests. So rather than run every test every time, developers can specify the test subsets they want to run, a huge savings of time and system resources. Second, DTM output is easy to read and is automatically stored in central libraries. The results can even be read from the language-sensitive editor. A touch of a key moves the cursor from the failed test to the point in the source code that caused it. Because DTM makes code easier to test, developers are willing to test their code. By testing more, they find bugs sooner, saving them the time, talent, and money they would have spent fixing them. And every defect found before shipping takes a bite out of the maintenance load later. That's how to bring down the demands of maintenance, bring new people up to speed faster, automate the maintenance tasks, and make testing easier. Software reliability is more than just a sound business goal, and more than a matter of personal ethics. Certification is now a vital issue throughout the software industry.
I think that the entire industry is going to be headed this direction, and I think it's fair now to ask software suppliers, what is your process? How much rework do you have? How stable are your code libraries? How much test coverage? How many of the branch points through your application have been tested? It's important information, and it really attributes a lot to the process that's used and to your expectations of reliability when you go to use that product.
The software development environment provides some of the best methods of software quality control in the industry. Ann Smith-Duncan, a software engineering manager in Tom Harris's group, has kept a close eye on Digital's performance in terms of product reliability, productivity, and the costs of producing new software. She's able to say conclusively that the success of Linda Zimmons' team with version 2 of the DEC Test Manager was not an isolated event. Across the board, Digital's productivity and quality increased while our costs per product dropped.
What we have found in this organization when we did a study to see how we've been doing over the last 7 years is we found that the quality of the work has improved significantly, and how much we're able to deliver has improved significantly. And even more important from a management perspective, it's costing us less to deliver high-quality products for our customers.
Here's a graph showing the productivity rates for 14 digital products from 1980 through 1987. The vertical axis represents productivity, or the average number of lines of code each programmer delivered per month of development. The horizontal axis is time. Each dot represents a different project. The slopes are regression lines and show the trends for the products released before 1985 and those released after.
By looking at the regression line, you can see a significant improvement. What we have found is that a number of the productivity tools were first available in 1984, and so they were being used on those products that were under development and delivered through 1985. And you can see that not only has the regression line showing that there's a vast improvement in terms of how much gets delivered for a particular cost, but also the slope has changed, which means we're actually able to do even more than we had expected.
Productivity is going up, reliability is going up, and cost per size is dropping. 7 or 8 years ago, Tom's group couldn't dream of delivering some of the products they deliver now. The costs would have been much too high. But what was prohibitive then may be conservative now.
We were able to deliver a product that was over 250% larger at the same cost. Actually, a little bit less cost, about 10% less.
Tom's group can now typically deliver 150 to 200,000 lines of code with about 5 people in a 2-year development cycle. That equals 1,200 to 1,700 lines of code per person per month, a huge number. They do it by reusing code and by using the tools in the software development environment. This means they can deliver code much faster than before, a plus for customer satisfaction. There's more of a chance to win accounts when competing with other vendors, and there's the freedom to move more quickly from project to project. But the bottom line, a shorter time to market means more profit for the company and meeting the needs of our customers sooner. Tom Harris designed a scenario to illustrate this. He's taken his facts from his own experience and from the experiences of others he's worked with. Let's consider a hypothetical 10-person development team working on a project. Their cost per programmer is about $100,000 per year. This includes labor costs, fringes, capital equipment, overhead, and so forth. $100,000 a year, or $8,000 a month per programmer. Now, this group does a pretty good job of product selection, so they can count on a 5-to-1 return on their expense. And for our scenario, let's say it'll generate a bit over $1 million of income in its first year on the market. Let's say $100,000 a month. Using their standard tools and techniques for software development, this is what this team already expects. Business as usual. Now suppose they invest $50,000 in some software development tools, and using these tools to accelerate their planning, designing, coding, and testing, they deliver the product 1 month sooner than predicted. 1 month. Doesn't seem like much, does it? But it is. First, because the product is on the market 1 month earlier, the company nets $100,000 more in sales. Second, it suddenly leaves that 10-person team with a month of free time. An extra month they can devote to work on another money-making project. At $8,000 per person per month, that's another $80,000 saved in salaries and overhead. The group is already $180,000 ahead. But at a 5-to-1 return over expense, that $80,000 worth of time put into the next project will come back as another $400,000. Altogether, our group leverages $580,000 on an investment of about $50,000. Think about the implications. They'll soon be completing entire new projects they would never have had time for. The one critical assumption behind this scenario is that the group must have some other project waiting in the wings. If they have an application backlog, that's probably not a problem. But if there's no backlog, they'll have to dilute the final figures. Now let's consider something called rework. It's one of the hidden enemies of software development. Rework is correcting formatting errors, misspellings. It's changing anything that could have been done right the first time. One study found that on average, 40% of all work done on a project is rework. So it can be a huge waste of time and resources. Worse than that, rework produces bugs. Not all the time, but often enough to be significant. If a group reduces their rate of rework, they do 3 things. They increase productivity because they're working on the challenges at hand, not cleaning up mistakes. They reduce maintenance because they reduce the number of bugs. And they save money because they reduce development time and maintenance costs. How do these tools reduce rework? LSE, the language-sensitive editor, provides full routine templates. That means that programmers can't forget vital statements, and misspellings are nearly eliminated. The module management system automatically compiles source code before building it. So if someone forgets to do it, it doesn't harm the build. By using the test manager throughout development, bugs are found early rather than just before field test, when they may be too deeply embedded in the code to correct. In addition, these tools actually let users monitor their own rate of rework. CMS, the code management system, is especially suited for this. Each time a person issues a CMS command, they must enter a comment explaining why. CMS keeps a record of these comments in its history file, along with who made the command, what the command was, and when it was made. Later, this information can be analyzed, categorized, and perhaps graphed like this. Each column represents a reason for rework, and its height shows its percentage of the total number of reasons. Note that the first 3 reasons account for 70% of the total rework. This group, having seen where their problems lie, can start to reduce the reasons for those problems. Anne recalls one group that used this kind of a graph to see why they were making so many changes in one particular week. They found that because they hadn't been using an LSC template to put copyright statements in the source code, someone had to go in and do each one by hand.
If they had done their LSC template up front and had all of that in there, then that work would have been eliminated. After realizing how much time it took to go and do that, they went and built their LSC template so they didn't have to do that again.
Another group wanted to take a look at their productivity, so they graphed their CMS Create activity. That is, the number of new modules entered into the library by date. This is what they found. The big spike on the left was not a surprise, as it coincided with a milestone in their development schedule. They expected a lot of productivity just then. But the spike on the right made no sense. It came 3 weeks after the New Year's holiday. It was a big spike, so something interesting had happened, but no one had an easy answer.
And as it turns out, everybody on this team had gone on vacation during the Christmas and New Year's holidays except one person. And he was so happy to be able to sit in his office without interruptions, design meetings, project meetings, code review meetings, that he was able to accomplish a phenomenal amount of work.
3 weeks after the holidays, the developer added his new code to the CMS library, and that's when the spike appears. But not only did this group find an answer to their question, they acted on it.
They changed meetings so that they're later in the day, so that they don't necessarily meet every day. He's changed his working hours so that he's able to have more uninterrupted time, because for him that is the best environment in which to work. And the project team as a whole is more conscious of the kind of work that can be accomplished when the right environment has been set up.
Setting up the right environment, digital software development environment. These tools are tailored to the needs of today's software developers working in the VAX VMS computing environment. They provide numerous solutions to the fundamental 3 concerns of development: how to increase productivity, how to reduce the demands of maintenance, and how to save money. They come into play at all stages of development, streamlining the process, preventing and locating defects, integrating, automating, simplifying, and accelerating development. In this video, we've discussed 7 tools in the environment. We've discussed VAXnotes, the code management system, the module management system, the language-sensitive editor, the DEC Test Manager, the source code analyzer, and the performance and coverage analyzer. 7 tools of the 11 in the environment. The 4 others are VAXDocument, a powerful system for producing software documentation, the VAX COBOL generator, a tool that actually writes COBOL code according to the user specifications, VAXScan, a pattern matching programming language, and the Software Project Manager, a versatile online system for tracking and managing software development projects.
We've seen higher and higher degrees of consistency across our projects. And quite honestly, the thing that's important to me is we've seen higher and higher gains in product reliability. The reliability translates into confidence for our customers, and it translates into lower maintenance costs for my organization, which means we're able to move into still new places that we need to be.